Okay, so this one is more difficult, and I'll tell you why. They're not asking for displacement, they're asking for distance traveled in 16 seconds. So the way I'm going to do this over here, I'm going to look at the velocity function, and this is vertical, it's going up, and then it's coming back down. So if you think the velocity function, Vt, is 90 minus 9.8 t, all right? So what I want to do is just talk about, when is it going up when it's positive? When is it going down when it's negative? Right? So what I want to do is, I'm going to say it starts at 0. This is t. This is velocity. At time equals 0. I'm talking about velocity now. And, where does it take on a 0? I'll write this down. It takes on a 0 when t equals a certain number. And what's that number going to be? Well, just looking at the equation, it would be when 90 minus 9.8 t equals 0, which means 90 equals 9.8 t, which means t is going to be 90 over 9.8. All right? So I'll write that down, 90 over 9.8. All right, we'll talk about units later, by the way. So, between 0 and 90 over 9.8, you pick a test point, like you pick, I don't know, maybe 1, and it's going to be positive. What does it mean? It's going up. It's going up. Now, after 90 over 9.8, take another test point, like 10, plug it in, it's going to be going down. All right, so it goes up, comes back down. So what I want to do is, I'm going to write the integrations down for you now. I want to do the distance going up. That's a positive distance, by the way. So that's going to be this over here. It starts at 0, and we're going to go up to, let's see, we're going to go up to 90 over 9.8. 90 over 9.8. And this is upwards, a positive distance. And what's the integration going to be? 90 minus 9.8 t dt. Now as it goes down, whoops, sorry about that. As it goes down, the distance is going to be negative. So I'm going to have to take the opposite of that then, because I want to get the total distance. So minus a minus, whoops, I keep doing that. Whoops. We're going to start at 90 over 9.8, and we're going to go up to 16. And what do you get there? 90 minus 9.8 t dt. All right, you're learning, and what we're going to do when we're learning is you want to see if you have met a milestone. And this is a milestone that we'd be looking for on an exam. And this is going to be distance. It's not displacement. The other ones are far easier to do, by the way. So I want to see if I got that there. And it's not easy, but let's see if we got that. So I'm going to say 0 to 90 over 9.8. I do see that. Oh, by the way, they're using something snappy over there. I wouldn't worry about that. It's tough to integrate that. I'd have to write this down anyway. I got this over here, dt. I noticed they brought something plus over here, and I want to tell you what they did, because I'm looking at it. And what they did was they factored a minus 1 out from that second integration, by the way. And if you did that, I will go through that with you, you would get, if you factor minus 1, you get plus, and then you'd get 90 over 9.8. Again, I factor a minus 1 out. It's not a big deal. What do you get? 9.8 t minus 90 dt. And I do see where that's coming from. Now, what I would say in exams, I don't think this would be a good question in an exam, by the way, because the arithmetic is kind of brutal. Right? It's kind of brutal, right? However, I do want to point out I could integrate. Right? I could write that down. Let me erase this over. I'm pretty happy that my answer looks the same as theirs. And if you're doing this over here, I'm going to say on exam, what I'd be writing down, let me go over here, I'd be doing this over here. I'd be writing down, 90t minus, well, it's going to be t squared, and 2 goes into 9.8 4.9 times. All right? Limits of integration there is going to go from 0 to 90 over 9.8. By the way, I'm not going to bore you with the details of doing the arithmetic, but the next thing I'm going to do is, the opposite of this guy's antiderivative. So I'm putting in parentheses, by the way. So 90t, and then it's going to be minus 4.9 t squared. Limits of integration, 90 over 9.8 up to 16. I'm not going to do the arithmetic, but you could do the arithmetic, and I would recommend using a calculator. It's really not that bad to do on a calculator. By hand, it's probably, more than most people would want to do, and to get a decimal number over there. Going back to the problem, though, talking about the units, it's meters per second, and we're integrating, so our answer is going to be meters, and this would be meters over here. So that's important, it's meters. Thank you.